Lesson 5.1, taking a look at the properties of exponents with definitions and examples. We have product of powers, power of a power, and power of a product. In these examples, we have bases being multiplied together with various exponents. I know this is kind of hard to read, and I'm not quite sure why it's so hard to read, but when we multiply bases that are the same, we condense that down to one base by adding the exponents together. That's why we have add right there. For example, if you have x squared times x to the fifth, you write it as just one base of x and you add the exponents together. And that's how we got x to the seventh. In the second example, power of a power, this is when you have an exponent and it's being raised to yet another exponent. So if you have two exponents and there's just one base, you multiply the exponents together. If you have m to the third power and you raise that to the fourth power, 3 times 4 is 12. Power of a product. You use this property if you have two things in a parenthesis, and often it's a variable and a number, like a coefficient. If they're both in the parenthesis and they're being multiplied, and there's an exponent on the outside, you can distribute the exponent in. For example, if you take a look at the right-hand side, I wrote a couple of solutions here, or a couple things to think about. For that first example, we have 7x in the parenthesis being squared. Because it's in the parenthesis, you can take that squared to the 7 and the x. So notice they each got the exponent. 7 squared is 49, and then x squared just stays that product, so 49x squared. The difference between the red example and the blue example is that the 7 isn't in parentheses with x. So if you see 7x squared, it doesn't equal 49x squared because the 2, that exponent, only goes to the variable that's closest to it. So 7x squared just stays 7x squared. You have to have a parenthesis to square the number out in front. The last thing for this example, if there's addition on the inside, this property isn't true. Remember, the name of the property is called power of a product. So you can't have addition on the inside if it's power of a product. So if you have 7 plus x and you try to square it, it doesn't equal 49 plus x squared. You'd have to write it out twice, like this, and then FOIL it. So you'd get a totally different response. Moving on to some of the other properties. If you have a negative exponent, a to the negative m, take the reciprocal of the base, so 1 over a, and that makes the exponent positive. So looking at the example on the right, if we have 4 to the negative 3 power, notice what I did was I took the reciprocal of 4, which is 1 over 4. I just put it in the denominator. And then 1 over 4 to the third power is equal to 1 over 64. If you have a base that's a fraction, take the reciprocal of the fraction and that moves 3 up to the top. So technically that's 3 over 1, but that would just equal 3. And all that does is make the negative exponent positive, and then you can evaluate it. 3 squared equals 9. Moving on, I know I'm going through these kind of quickly, but I hope this makes sense just kind of hearing this verbal explanation. The zero exponent property is a nice one. It's pretty easy. If you take a look at anything that has an exponent of 0, it always equals 1, no matter what. So if you just have a base, like x to the 0 power, that equals 1. Even the parenthesis with addition, I know we talked about that up above, but if you have a parenthesis raised to the 0 power, also equals 1. The last example, though, this kind of ties into the example highlighted in yellow up above. 5y to the 0 power. Notice the 0 is just with the y, so y to the 0 equals 1, but 1 times 5 is going to have a product of 5. So that's why that answer is not quite the same as the other two. And then we move on to the quotient properties. We've got a quotient of powers and a power of a quotient. If you have two bases that are the same and you're dividing, you simplify it down to one base by subtraction, and it's m minus n. I hope it's easier to see in your printout. I'm not quite sure why it doesn't look so specific in this video, or in this lesson. Not sure why it's not showing up so well. So the examples that I gave on the right, x to the 9th divided by x to the 4th, you can condense that down to one base by subtracting, and it's always numerator minus denominator. Notice in the blue, the r's, if I do 2 minus 11, I actually got a negative exponent, r to the negative 9. I took the reciprocal of r, which put it down into the denominator, and made it 1 over r to the positive 9. And the last example, power of a quotient is kind of like power of a product, but instead of multiplying inside the parenthesis, you're just dividing, so it's a fraction. And if you have two different bases with a parenthesis, they both get the exponent. So over on the right, 2/3 cubed, you would cube the numerator and the denominator, and then find out what that power equals. 2 cubed just means 2 times 2 times 2. 3 cubed means 3 times 3 times 3. And that equals 8 over 27. If you have a negative exponent, look at what I did here. I took the reciprocal of the fraction and made the exponent positive. So I didn't do 1 over 2 and 1 over 3. I just recognized if it's already a fraction, taking the reciprocal of the base just flips the fraction. And then you can distribute the 3, because it's positive, to both the numerator and denominator. And that gave us 27 over 8. Looking at each of these examples, we just evaluated using the properties up above. For question 1, we combined the exponents by adding them together, and we got 6 to the negative 3. Because the exponent was negative, we took the reciprocal of 6, which made it 1 over 6. And that changes the negative 3 to positive 3. Notice we have a tiny answer, 1 over 216. Question 2, 5/2 to the negative 3 power. Notice I took the reciprocal of the base, and then I distributed the exponent to both the numerator and denominator. 2 cubed is 8, and 5 cubed is 125. Question 3 is a power of a power question. 7 to the negative 3 to the power of 2 on the outside. We multiplied negative 3 times 2 to get negative 6. Because the exponent was negative, we took the reciprocal of 7, and then 1 over 7 to the 6th power is 1 over 117,649. In the last example, notice we have 3 bases that are the same. We combined the exponents just by adding them all together. 6 plus 0 plus negative 5 is just 1, and 2 to the 1st power equals 2. Down below, we have combinations of numbers and variables with different types of exponents. In question 5, all the bases are the same, kind of like question 4. So we added the exponents together. 3 plus 8 minus 4 gave us b to the 7th power. 6 has 3 bases on the inside, the 3, the m, and the n. The first thing we did was we got rid of the outside parenthesis by distributing the 4 to all of those bases. 3 to the 4th power is 81. So on your calculator, you can do 3 times 3 times 3 times 3. Or there's an option, if you press 3, there should be a button on your calculator that looks like an arrow up. And that just means you're raising your base to an exponent. If you type 4 in after that and then enter or equals, you should get 81. So that's where we got that number. M squared to the 8th power, or m squared to the 4th power, that's power of a power again. We multiplied to get 8. And then n to the 4th power, nothing changed there after we distributed the exponent in. Our final answer was 81, m to the 8th, n to the 4th. And then that last one, number 7. We don't have any number bases, but we have x's and y's. What we did first was we got rid of the parenthesis in the numerator by distributing that outside exponent in. That made power of a power, and that's how we multiplied to get negative 6. Power of a power, we multiplied to get positive 6. Then what we did is recognize that we have an x on top and bottom of a fraction. Since the base is the same, we subtracted, so we took x to the negative 6 minus 5, and that's how we got negative 11. So x to the negative 11th. For the y's, we did 6 minus 6, and we got 0, and that gave us y to the 0 power. Well, y to the 0 power equals 1, so we just cancel it out of the process, because anything times 1 would stay the same. And then because x had a negative exponent, we took the reciprocal, 1 over x, and that made our exponent positive. So I hope hearing that explanation as you're looking through your notes was helpful. Please let me know if you have any other questions.